Hello and welcome back. For this video, we'll be discussing general relations. There is a PDF available for printout if you'd like to follow along. A couple of definitions. A relation is any set of ordered pairs, so any set of x and y. Domain is the first coordinate of the ordered pair. We also call it the x-coordinate, so this is really domain. And the range is the second coordinate called the y-coordinate. That would be range. So x and y are really domain and range. You notice that alphabetically x comes before y, the same thing, domain comes before range. We've talked about a function before, but what we're going to describe now is a function is really any relation in which different ordered pairs have different first coordinates. And we'll show you what we mean. This would be a function because each x is different, so it's a different first coordinate. If we had 3 and then let's say 5, you'll see that we have the 3 come up twice. Now the 3 being there twice is not really what prevents it from being a function, it's the output that matches it. You'll see that the 3 matches two different outputs. So yeah, we got a 3 twice, but the reason it's not a function in this case is because I have a 4 and a 5 matching the 3. So that would be a one-to-many, not a one-to-one relationship. Example 1, we want to graph each relation and tell whether it is a function. Okay, so A is graphed right here, and you'll look for common x values. So here's the x values. Here's two common ones. You'll see those are right here. Now, if they have the same output, they would be a function, but since they have a 1 and a 1/2 as the output, they are not a function. You'll also notice how they're stacked up vertically on top of each other. That's not a function. B, this one is going to be B right here, and we're graphing the absolute value of x plus y is equal to 3. So if we turn that into mx plus b, what we'll get is a negative absolute value of x, which creates an upside down v. Now what happens here is each time we go to an x, let's say this x here, there's only one output of y. If we go to this x here, there's only one output for y. This x here, there's one output for y. So we have a one-to-one relationship, even though this goes infinitely in all directions. So that is a function, a one-to-one relation. If we go over to C, this one is C, you'll notice this one has an inequality on it. So the shading occurs either inside or outside of the V shape. So it's an absolute value, so it creates this V shape, but the shading occurs inside the V shape, which is all in here. Now if we go to, let's say 1, which is here, we go up, we can put a point there, and we can put a point there, and we can put a point there. So for that value of 1, so this is a 1, for that value of 1, I came up with 3 different values of y. So that's like saying 1 positive, let's say 2, 1 positive 3, and 1 positive 4. And I just made up those numbers for these dots here, here, and here. But what you'll notice is I have the same x value repeated multiple times, but I don't have the same y value matching. I have different values. So this one is not a function. Example 2. One of the easiest ways to determine if a graph is a function by looking at it is to use the vertical line test. And this says a vertical line test. A relation is a function if and only if no vertical line intersects its graph more than one place or one at a time. So let's use this red line as our vertical line. As I run it across this graph, you'll see that it only touches the graph once at any given time. So if I stop here, it touches right about there. But if I move over here, it touches right about there. And I can move this over infinitely left to right. It only touches the graph one time. So this is a function. If I go over to B, now remember there's supposed to be arrowheads here, so let me go ahead and put some on there. Those go infinitely outwards, but they're not going to get vertical. So as I run this across, you'll see it only touches the graph once at any given time as I move it across. So this would also be a function. Let's go down to C. As I move this across, it touches once there, but as I come over here, you'll see that we have it crossing twice. That's a 1x matching two different y values. That's not a function, and that's enough to call it not a function, but you can see over here it also touches the graph twice. Even though it only touches once there and once here, there and there are twice. So this is not a function. So the vertical line test becomes pretty easy once you see a graph visually. So you can use your pencil or actually just draw a series of vertical lines to represent the vertical line test. If it passes the vertical line test, it's a function. If it doesn't, it's not a function.